Alright, so I'm here on Desmos. I know you used this last year, so this is a great program to be using on college algebra and any of your online classes. But I'm here to talk a little bit about graphing. Now, what I'm going to talk about is how adding things to the equation and kind of changing that equation can affect how the line looks on the graph. If that's, I hope that's kind of what you're looking to get some help on. If it's not, let me know and I'll try something else. Or I'll do whatever else it is. But this is something I always kind of struggled with, and I always feel like I've struggled teaching a little bit. So kind of bear with me through this. But I'm going to do my best here to explain what it is that's happening. So effectively, there's two major equations we have, especially in college algebra. There's two major ones we care about. There's the linear function, which is y equals x, and then there's the quadratic function, which is y equals x squared. So you'll notice the linear function is literally just a straight line. It's this diagonal one here in purple. The black line is our quadratic parent function, our x squared, which turns into a parabola. I'm going to talk about these separately because they each kind of change in slightly different ways, but it's easier for us to talk about this linear one first. Now, if you recall, what happens is linear equations are y equals mx plus b, right? Slope-intercept form, that's what they are. So if we have y equals x, then effectively what this is saying is it has a slope of 1, because that's our coefficient to the x, and it has a y-intercept, or a b, of 0, because it doesn't actually say anything there. Now, the easiest way to move this around the graph, to kind of transpose it somewhere else, is to add or subtract to this, adding in a y-intercept. We'll talk about the coefficients later, but the y-intercept is the big thing. So if I say plus 4, actually let me leave this parent function, this original one here, so we can see how this moves. So if I say y equals x plus 4, what you'll see is this actually moved, and I would be willing to bet this actually moved counterintuitively to what you expected. Because if we have y equals x plus 4, this is actually moving 4 to the negative direction. Even though it's saying plus, it's actually moving in the negatives. Now the reason for this is because originally y equals x, right? If one is 0, the other is 0. But if now y equals x plus 4, we actually are kind of like adding this 4 to the x to make the x catch up to the y. It means the x is always going to be 4 smaller than what the y is. So that's why our x-intercept, the point where it crosses this x-axis, actually moves backwards on the graph. You will notice, though, that our y-intercept, like I had said it is a positive 4 right here, right? Like the y-intercept stays at that positive 4. So adding moves it backwards, again, counterintuitively, but subtracting also works that same way. It moves it forwards. If I do x minus 3, it's actually moving it up 3 on the graph to a positive 3. Now this works, adding and subtracting to it works really well whenever we're specifically talking about a x with a coefficient of 1, like this is. It gets a little bit more difficult when we change that coefficient, because that coefficient, again, is the slope, right? So if I said 6x, then you're going to notice this red line turns a lot steeper than the original parent function y equals x that we had, because the slope is now not 1, it's 6. In that same vein, if I made it 3, it's still steeper because it's greater than 1. However, if I wrote it as a fraction, 1 over 5, then it's going to get a lot less steep, a lot closer to this x-axis, because, well, its slope is now 1/5 of what it was, and it's, like I've been calling it, the parent function. So that slope is pretty straightforward, either making it steeper or less steep. But if we have a slope attached to it like this, 4 as the slope, if we add or subtract to that, then it actually kind of makes things a little weird. Because if I subtract 3, then you'll notice this is no longer at 3. It's not moving it, 3 to the positive all the way over here like it would. It's moving it to 0.75. So that's a little bit unusual, right? But what you'll have to do is you'll actually have to look at this not necessarily as a way it moves in the x direction or the way it moves on the x-axis, but you'll really have to look at it more as a y-intercept, because that's what this is in this case. This -3 is a y-intercept that crosses at -3 on the y-axis. Because just in the same vein, if I would make this a positive 5, we're still moving a little kind of weird along this axis, but you'll notice I am in fact crossing it at 5 on the y-axis, so that y-intercept still has meaning. Just a fun little fact, because I like to mention these things, is it crosses at negative 1.25. That's the coordinate on the x, and you'll notice that 4 times 1.25 is 5. In that same vein, if we would have kept this with the minus 3, this crosses at 0.75. 4 times 0.75 is 3. So it still fits that kind of thing, but it's kind of like you move it over as much as this number divided by your slope there. So it's kind of weird, and it's easier to just look at the x-axis or the y-axis, the y-intercept. But yeah, it has kind of a weird, kind of unusual relationship. So that's it with linear functions. That's the big deal with linear functions, how you add to them, how you multiply them, that kind of thing. If you have any other questions on those, let me know. But let's talk about a quadratic function, a function that is x squared. Now, this, of course, is not y equals mx plus b, because this is not a slope-intercept form. This is actually much closer to the equation of a circle. This is y equals, if I could get this to delete here, there we go. This is y equals x minus h squared. Squared, there we go, plus k. So I know this is kind of a weird equation, but this is x minus h squared plus k. So you'll notice here that the h is still what I would like to call the center point of the equation. So the center point being the point on the x-axis where this vertex is, this either lowest or highest point, depending on which direction our parabola is oriented. So this point is our h. That's what it is. The k is the y value of this point. So you'll notice right here, this is at 0, 0. Well, that's because I don't have x minus anything, that's 0, and I'm also not adding anything to it, so that's 0 as well. So you'll see here, if I kind of change this a little bit, let's do x minus 3, square it, and then add, let's just add 0. I don't really have to write plus 0, but just for the purposes of showing you here, this is what's happening. So you'll notice I put minus 3. Now again, this is really important, and I talked about it in the circle videos, but since this is supposed to be x minus h, when we have this subtraction here, that actually means 3 is a positive number. We're subtracting a positive. If we are adding there, it actually means that is a negative number. It's opposite of what you're seeing. So this means h is 3, so our center point should be at 3 and then k, 0. If you look here, our center point is at 3, 0. That's where our vertex is. So if I just try something else, I say x plus 4, x plus, and then plus 2 at the end, I should be looking at negative 4, because again, minus h, so if I'm adding, that must be subtracting a negative. So negative 4, positive 2 for k, because I do not have to change the signs on this. It's all by itself. It's supposed to be adding. So this would be negative 4, 2 is my vertex. We look right here, this red line, negative 4, 2. There is my vertex. So adding to the x within these parentheses is going to move it left or right along this x-axis. It's going to move it opposite of the sign that you're putting in. So if you add plus 2, you'll see that it moves it to the left 2. If you add minus 2, you'll see it moves it to the right 2, so on and so forth. Adding a number outside of these parentheses will move it up or down. So plus 4 is literally going to move it up 4, minus 4 is going to move it down 4, all the way down to negative 4 on the graph. I know it's a little bit weird because you have to remember that these signs mean the opposite of each other, kind of, because right here it's supposed to subtract, so this is the opposite, it's moving in the opposite direction of the sign, but this is supposed to be positive, so it's moving in the same direction as the sign for this number on the outside. I recognize that you're not always going to get it written in this format. A lot of times it's going to be written as a polynomial. It's going to be written more so as something like y equals x squared plus, I don't know, let's say 2x plus 1. And then things get a little bit weird, right? Like that's this blue one right here, but you have to ask, why is it that blue one? It didn't actually change much, it just moved over, right? This is actually goes back to being able to complete the square. If you recall completing the square from last year, which I know is a whole other lesson in and of itself, but if you recall that, then you'll actually realize that we can simplify this down, we can factor it, and we can turn it into a perfect square polynomial, because this is actually the same thing as x plus 1 squared plus 0. So you'll notice it kind of overlapped that exact same line, the blue line and the green line. It's exactly the same here. And that is because we just factored this. We just saw factors of c that add up to b, factors of 1 that add up to 2, 1 and 1 add up to 2, and they multiply to 1. So these are actually the same thing, weirdly enough. But that is completing the square. That's kind of a whole other ordeal, but that's what it is. The last thing I want to talk about with this is if we see a, let me get this back to written in x plus h, or x minus h kind of deal. X minus 2, and then squared, and I'll do plus 3, something like that. So we see it up here. What's going to happen is if we put a coefficient on the outside of this, it's going to change it. First off, if we put a negative, it flips it down. So if you ever see a negative in front of the x squared or a negative in front of those set of parentheses with the x, it actually means that the parabola is oriented upside down. It has a highest point or a maximum instead of a minimum like we have in this case. Additionally, if you were to put a whole number coefficient there, like 3, and actually, let me just change this to x squared again. If we were to put a coefficient in front of it like 3, you'll notice it gets a lot narrower. The same goes for if we put a fraction there, 1 over 3, it gets a lot wider. It's kind of like slope. Whenever we have a bigger number than 1 for the slope, we get a lot steeper, and that's what's happening to these lines. They're becoming a significant amount more steep. If we have that fraction, 1 over 6, say, then it becomes a lot less steep than the standard line, than our parent function. It kind of lowers itself a decent bit here. So those are the couple of things I would talk about with graphing, with whether you're adding to the x or adding kind of outside of the x in the quadratic form, if you have the coefficients or if you have it a negative. The negative's kind of a big one that you're probably going to see a lot on assignments, just figuring out that orientation. Again, with the linear stuff, just remember it's slope-intercept form, being able to look at that y-intercept, looking at the slope for graphing it. If you have any other questions, if you need help on like graphing it on paper or something like that, let me know. If you have any other questions, you know, x to the third maybe kind of problems you're doing, whatever it is, I'm more than happy to help. I'm actually pretty excited. I found out I can record Desmos like this. I didn't know that till just now, so I'm pretty excited about that. But yeah, just let me know if you have any other questions. Hope this helped.